So as you know, every day we try to pick one question from interview experiences of lead code and try to solve all the possible follow-ups of that question. So yesterday we picked up this interview experience of Microsoft SD2 and we have already solved the first question of this interview experience. I will link the video in the description below. It was a pretty good follow, like this question has a pretty good follow-up, so you can watch that video. In this video, we will be going over the solution and the follow-ups of the second question. So let's start. The question states that there is a 1 day long training session which will be conducted twice during the next 10 days. So we have a period of 10 days. In these 10 days, a training will be conducted twice. And we have n employees. Employees are numbered from 0 to n minus 1. Each employee will provide a list of its availability for the course or for the training. We need to find the maximum number of employees that can attend during at least one of the two scheduled days. So we have to schedule the training session in twice in these 10 days. So we have to find these 2 days efficiently among these 10 days such that maximum number of employees can attend the training. So let's understand this with an example. So let's say employee 0 says that he or she can attend the training at day 0, day 3, and day 9. Uh, Employee 3 says that he or she can attend the training if training was conducted on day 3 or day 2. So that's what this mapping means. This is given to us. And second thing is, like, we have been given that there are total 10 days and we have to select 2 days among these 10 days. So let's say we choose these 2 days, 3 and 4. So if we choose these 2 days, 3 and 4, we can see employee ID 0 can attend the training because uh, it is it has shared that availability, uh, he or she is available on day 3. So employee with ID 0 can attend the training. Similarly, employee with ID 1 can attend the training. Employee with ID 2 can attend the training because of this 4. Employee 3 can attend the training because of this 3. Employee 4 can also attend the training because of this 3 or this 4, anyone. But employee 5 can't attend the training because he or she is neither available on day 3 or on day 4. So that's where the, like, if we select 3 on fourth day, if we plan to conduct the training on day 3 and day 4, then 5 employees can attend the training, and that's the maximum thing we can get. So we can't schedule the training on any of the other days such that all 6 employees will be able to attend. So 5 is the answer. Now, how to solve this? So looking at the very brute force solution, it is very simple. Basically, we need to choose 2 days among these 10 days, right? And we just need to see how many employees are there who can attend the training on the selected dates, and among all the possible combination, we will pick up the combination which gives us the maximum number of employee count. So the algorithm is pretty simple. We will just iterate over day 1 and day 2, and for each employee we will then count whether the current employee can attend the training on day 1 or day 2. If they can, just increment this employee count, and at the end just take max of employee count across all the possible combination of day 1 and day 2. So this is pretty simple. Like the just to let's just look at the code quickly. Again, this is the availability vector. As discussed, we just iterate over these 2 days, and we then iterate over every employee. And based on whatever days they are free at, we are checking whether that day is either equals to day 1 or day 2. If they are, we are incrementing our unique employees variable and breaking from the loop. So at the end, these unique employees will contain how many employees can attend the training on either day 1 or on day 2. And after finding this unique employees value, we will just take the maximum across all the unique employees. So this um, is pretty simple. Now let's just uh, quickly calculate the time complexity of this. So let's say there are d days. So the first loop will run for d time. Second loop can also run for d time uh, in worst case. So d square comes here, and for each of them we are iterating over each employees. So let's say the number of employees are e. So that's where e comes from. Uh, this is the overall time complexity. Again, within each employee, we are uh, basically checking this list as well. So assuming that this entire list is constant, like the average size is constant, so that's where like I am not counting that in the complexity, but that can if that comes, like if in worst case the size of a single list can be uh, d, so in that case we will just add another d to the time complexity. So this d denotes the size of this list for one employee. So overall the time complexity is this. Now let's just look at up like instead of optimizing it, let's look at one uh, interesting follow up. So currently what we have is we have two variables, total days, uh, total days this training program will run, and repetitions. So maximum number of days course can be scheduled. So currently this repetition value is 2, and total days this program runs is 10, right? So now uh, one interesting follow-up could be what happens if we if these two are not constant. Let's say total days is something not 10, it is, let's say, d. Okay, so how will the solution change? So if you look at the implementation, so basically whatever our previous implementation was, here we are actually iterating till d minus 1, right? So even if d changes, our solution will not be affected. Like this solution will still be valid. But when what happens when this r like this, let's say the number of repetitions is denoted by r, so what happens if r changes? So then the solution will change, because currently what we are doing is we have to select uh, 2 days from this 10 days, right? So that's where we have this two loops, two for loops. But if this is dynamic, let's say there are repetitions, we can't let's say the value of r is 3, so we will have to add another for loop here, like for day 3 equals to day 3 equals to day 2 plus 1 up till d minus 1. Or if r equals to 4, we have to add yet another for loop for day 4, and so on and so forth. So doing this, uh, like if r is coming from, let's say, uh, outside of program, let's say r is an input to your function, in that case you will not, like this solution will not scale, because the current solution, we have hard coded the number of for loops. So that's where this solution will not work. So what would be the approach to solve that particular question where r is not a fixed value, it is an input to the function which can be variable. So interesting, like what we have ended with, we have basically ended with a problem where we have given d days, and we have to select r days from these d days on which we will schedule the training. And for all this combination, we will then check how many employees are there who can attend on this particular set of r days, and we will take the maximum across all such combinations. So the time complexity would be simply like we have to select all the combinations across, uh, like we have to select basically our days across these d days. So the basically we need to find these dcr, like this is combinations of math. So we have to find all the possible combinations of this dcr. So that's what the problem is now reduced to. So how to solve this problem? So what we are solving now is how to calculate the vector of DCR. So just to give you an example, let's say R is 2. So if R is 2 and let's say this is the list, basically D is 6. So because D is 6, we are ranging from 0 to 5. So now if R is 2, what will be the output of this DCR? The output will be something like 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4, 0 comma 5, and then 1 comma 2, 1 comma 3, and so on and so forth. So basically this would be the uh, output that we are looking for if R is 2 and D is 6. So we have to find this entire list efficiently, or at least there should be some way. Currently we are not able to find this list at all because of that nested for loops. So I will encourage you to pause the video and think about the solution for a minute. The solution is pretty straightforward. We will now look at the solution. So what we want is, we are sure that we can't have this nested for loops in first place, right? Because the value of r is not known to us, so we don't know how many for loops to put in this nested thing. So remember that whatever you do with for loop can also be done using recursion. So whenever you see this kind of nested structure and you need to serialize it for some reason, recursion should be the way to go. So let's try to understand it. So let's say so recursion, like again, in recursion what we actually do, we actually try to reduce the problem into the same problem. So let's do that here. So what we have currently is this set of list, right? 0 to 5. And for the purpose of this question, let's assume that r is 3. So r is 3, and we have this set of list. So let's denote this by D, like 0 to D we want to fill, and let's denote the number of things to be pick up with R. So now let's first talk about, or let's first only see this 5. Okay, so we can do two things with 5. Either we can take it, or we don't take it. That's the two possible combination, right? So if we take it, let's say we take 5 in our answer set. So 5 is there in our answer set. So then what we are saying basically, we have reduced the list size to 4, or 5 basically, and we have reduced the value of r to 2. So r denotes the number of things to be taken, right? Number of days to be taken. So we have already taken 1. So r will be reduced to 2 and d will be reduced to 5. So basically we have just reduced the problem into a sub problem which exactly looks what the actual problem was. So I hope you can see the recursion. So if there, let's look at the other possibility as well, wherein we are not taking this 5. So we decided that not to take 5 at all in our answer set. So in that case, what will happen is, we have reduced the d to 5 because we have decided what to do with the last element. And we have not like we have still 3 elements to be picked up. So basically we have again reduced our problem set. We have reduced d in that case, in this particular case. So hope you can see the recursion here. Let's try to write down the function f of d comma r. So f of d comma r basically denotes all the possible combinations of choosing R elements from 0 to D, and the return type of this f of d comma r will be a vector of int. Basically, this vector of ints denote uh, what is the like what is the current choice. So basically, you can see this is the vector of int. So this is first vector, and this entire list is a collection of vectors. So that's where the return type of this f of d comma r is vector of int. Uh, where inner vector, every inner vector is of exactly size r. So now let's try to write the formal recursive function. So let's say we want f of d comma r. So what we will, like, we have two choices as we have just seen. Either we will take the dth day, or we will not take the dth day. So if we take the dth day, the problem will then be reduced to d minus 1 comma r minus 1. Okay. uh, and what we are saying is, return me all the possible combinations of this particular scenario, wherein we have to select r minus 1 days from d minus 1 days. So let's say this returns a vector x. Okay, and x has, let's say, 5 elements. So first vector, second vector, third vector, and so on. Okay, now what we have what we have decided was, we are taking the dth day, right? That's where we have reduced this r to r minus 1. So this vector denotes number of, like, this vector denotes one of the way to select r minus 1 from remaining d minus 1, right? And we have to find the number of ways to select r from d. So the last one that we are selecting is d, so we will just append d to this entire set of vectors, and this will be our new vector, which we will push in our answer. So if you don't get this, please rewind the video and watch the last 2 minutes again. So basically, what we are saying is, we have to select R elements from this set of D elements. Now we are uh, because we have decided what to do with the dth number. So we, like, currently we are saying that we will take this dth number. So that's where we have queried this path. Basically select r minus 1 from the remaining d minus 1, and whatever set of vectors we get, we append d to each of them, and then add this entire set to our answer. So our answer will contain all these three vectors with this d appended to each of one. So this is the first part where we have decided to take D. Second part is where we will decide not to take D at all. So in that case, we will call f of d minus 1 comma r. Basically what we are saying is, select all the r elements from the remaining d minus 1 elements. Don't care, like, and this element, just think this element doesn't exist at all. So in this case, it will return y. Let's say y will again be a collection of vectors. So let's say the y contains some vectors. So because this vector actually denotes the set of R elements that will be picked up, we will just append this to the answer set without modifying it. So hope this approach makes sense. Now let's just look at the pseudocode of this to make things more clear. So this will be the rough pseudocode. Basically, what we are doing is, uh, first we are calculating a vector. Like, this without will again be a vector of vector. So we are calculating the ways without where we are not taking this d at all. In that case, we are saying that just take the r elements from the remaining d minus 1 elements. And we are taking the case where we are taking d element, we are selecting the dth day. So we have selected one day, and so we are remain with r minus 1 days to be selected from the remaining d minus 1 days. Now once we have this with and without, we will just initialize our result with without. Like, without actually denotes all the r days from this d minus 1 days. So basically, there is no involvement of the dth day, current dth day, in this without. So we'll just initialize this result with without. Now for like, if you remember, for with we have what we have said is we have we have selected the dth day already, right? So that's where we are iterating over each vector of width. Let's say the current vector is v. We will append d in the vector, in this vector, because we have also like this vector like v contains r minus 1 elements, and we have to select r element. So rth element is, we are saying that is the d element, is the dth day. So we append d to v, and then we will just add v to the result vector. So hope the approach makes sense. Let's look at the code to make it more clear. So this is the code. Basically, what we are doing is the same thing. We have just uh, okay, and then just a second. So this is not the code. This is the code. So what we have done is we have just queried, or basically find out all the possible combinations of selecting these many days from 0 to this total days minus 1. So if you remember, the actual problem states that the days lies from 0 to d minus 1. So that's where this minus 1 comes from. And for all these possibilities, what we are doing, we like each possibility will contain a selected day vector. Basically, this selected days vector will be of size repetitions. Now, for each selected days vector, we are iterating over every employee. We are seeing that uh, if that employee is available on this selected day set or not. So we just convert this vector to set for so that this search become efficient. Now, if this employee is indeed share his or her availability on this particular day, we will just increment our unique employees count, and after this loop, we will have all the employees who can attend on one of these selected days. So we will just compare it with the maximum attendance we have till now, and if current employees current count exceeds that previous count, we will just return that. So now just let's look at the function get out combinations. So as discussed, this function is doing the same thing. It is taking current day. You can think of it as d, and it is also taking this repetitions left. You can think of it this as r. Now we will look at the edge cases again. First, what we have done is we have found the combinations for remaining repetitions if we have taken the current day. So basically, this will denote whatever this will return a vector of vector. All the inner vectors will be of size repetitions left minus 1. Now we are, for each such vector, what we have got here, we are just appending the current day, because we have said that this is a part of the answer. So for selecting our days, we are selecting one dth day. So that's where we will just append this to the set that we got, and return, like just push this entire vector each to our result set. Now second is we don't take the current day. In that case, we just get all the combinations for d minus 1 and r, and because this this combinations assumes that d day there is no involvement of d day dth day at all. So we just we are just iterating over each of these combinations that we got for not setting the current day, and pushing that exactly to our result set, and then returning the result. So hope this approach makes sense. Now let's look at the space and time complexity of the solution. So basically, uh, what we have done is we have this. Let's just look at the code again. So we have this recursive function, right? So either we can try to think of this recursive function and see what is the time and space complexity, or there is a nice way. Basically, what we have done is we have just calculated the value of ncr, right? So and choose r. So we that will be our time complexity. Uh, into this R as well, because every time if you see, we are also iterating over each of these array that we have found in intermediate arrays. So that's where this R comes from. So if you just talk in a brute manner, this is a n factorial kind of solution. Okay. Now where n denotes the number of days, not employees. So this is the solution. And coming to space complexity as well, it is space complexity is even worse. Space complexity is also an order of n factorial only, because we are actually storing all these combinations in a vector. If you remember, like we are actually storing all these possible combinations in a vector of vector. So this vector will be of size n factorial approximately. So that's what the space and time complexity are. So as a first step, let's try to improve the space complexity. Let's not worry about time complexity for now. Even improving space complexity is quite interesting. So what we have done is, like, I will talk in general. So in general, whenever you, like, you get the case where you are first finding all possible combinations and then iterating over it to make some sense of it, then it is always possible to reduce the space complexity. We don't need to store this entire combination. So what we are doing is we are storing the entire combination and then we are processing it. So basically we are storing let me just erase some of the things here. So what we are doing essentially is we are storing all this combination first, and then the second stage is to process the combination, like to process each element. So that's what our current process is. So but what we can do, we can do something smarter. So what we will do is, as soon as one of the vector is ready, let's say one vector of size r is ready, so instead of waiting for other vectors of size r to be ready, like instead of waiting of the entire combination, let's pass it to the next stage and process it all together. Like let's pass it, process it, and then store the actual result instead of storing this r. So in our case, actual result is just a integer. Whether, like, how many employees, like what if you look at this, for each of this selected days, we are actually processing this part, and the output is basically the unique employees count. So that's what I was saying. Instead of storing all these combinations in a vector and then passing everything to the process stage and it will just return a list or something, we can, what we can do, we can pass this to process first vector to process list, return the list. In our case, this will be the count of employee, and then instead of storing this result, we will just store the count of employees. So that will bring down the space complexity drastically, right? So basically what we have to do is we have to shift this entire combination somewhere here. After everything is processed, we have to shift this entire combination there and then process it. So I will just give you a hint for now. So basically we will do something like uh, okay, so we will do something like just a second. So this is the thing that we will do. So first we will currently we have f of dr, right? We will then add a new dimension, like all the selected days, because what we need at the end is this vector only, right? So once we have this, like we will also keep this calculated, and every time we pass, so let's just look at the example again. So we are passing this d minus 1 and r, right? R minus 1. So every time we are passing this d minus 1 and r minus 1, we will also pass all the selected list of days that we have already selected. So instead of calculating the vector, we are actually passing the selected list of days. And inside this function itself, we will then process all this selected list of days. Basically we have selected days at the end, and you will do this processing and just return this number from the instead of returning this entire vector of vector, we will just return the integer that will denote the maximum attendance possible if all the days in selected days are already selected, and we have to still select our days from the remaining 0 to d days. So I will leave this to as an exercise for you to implement this part of the solution. It is quite interesting and it is quite extensive as well. Like whenever, as I told, like whenever you see this kind of thing where you are storing everything and then processing it to get something else, you can do it efficiently. Basically you can instead of storing the entire thing, as and when you get something, you will do the processing, get the processing output, and then you return it instead of returning this entire thing and then storing it. So that will bring down the time, that will not bring down the time complexity, but that will bring down the space complexity a lot, because we will not be storing this entire n factorial vectors in memory. So if you can implement the solution, and if you want me to verify it, as always, feel free to put the solution in the description below. I will help you verify the solution and tell if you can, if that is correct or not. So there are couple of more follow-ups. So if you have like if you have followed, we have just improved the space complexity a bit, but we can also improve time complexity of this equation, and we can improve a lot. So I will encourage you to think about how to optimize the time complexity of this question, and I will be posting another video tomorrow where we will be discussing about how to like like we will start from this point where we have left, and then we will try to see how exactly, like what's the thought process in optimizing the time complexity. And in the meantime we will discover some interesting follow-ups. So there are still some interesting follow-ups of this question, so we will uncover them tomorrow. Until then, try to solve this particular follow-up, and I will post a hint in the description below. So if you are stuck for some time, look at the hint and then again try to solve the question. So thank you for watching. If you like the content, please like the video and do share it with your friends so that they can also get benefited. I will see you tomorrow.